So this is the second video lesson on the microscope. First one talked a little bit about development of the microscope and then types of microscopes. This one's going to focus on the compound microscope and a bit about its use, because that's the one we'll be using when we do labs. So you were supposed to go through and identify the parts and functions of the microscope, and this will be better whenever we can do it in class, but I'll go through it here anyway. Oh, I think I have some munchkins are up now. And yeah, you can play my phone. I don't know how many games are on there, but you can play it. Okay. So, let's take a look. When you're looking through a microscope, you're going to turn on the light source. Why is it doing that? Okay.
Now for me.
Oh my goodness, that's a lot of games. You can try them.
Oh,
Sorry. He's 4. He's loving learning technology. Okay, so back to the compound light microscope. Okay, so turn on the light here. Okay, and the light will shine up through, and then we can look through here. So we're going to talk about the parts. Number 8 is showing light source. Okay, so basically it shines the light up through the specimen, up through the objectives, towards your eye, so that you can see it. Now, just above it, under the stage, is a part called the diaphragm. And the diaphragm we can adjust in order to change the amount of light that gets through. So if we find that we can't see very much, you can barely see it, you might want to adjust it so less light goes through, so it kind of darkens it a bit, and then you might be able to see more detail. So that's a diaphragm. And in this particular case, this one has a lever, and it's pretty thick. So I can tell, because it has a lever, which you would kind of slide along in order to adjust the size of the hole that the light goes through, I know this one is actually an iris diaphragm, so I can be more specific. Most of the ones we'll use are disc diaphragms. So it looks like a flat circle with holes on it of different sizes. And so you turn the circle and put the hole of different size in place. So that's the diaphragm. This part here, so it's listed as number 11, this is the stage. And the stage is where we place the sample, the slide with a sample. So it's there in order to hold as a place for the slide to sit, and it also moves up and down to allow us to focus on or view the specimen. The stage clips, number 6, pointing to the stage clips, they hold the slide in place. Okay, so those are the stage clips. And again, this will be moved up and down for us to be able to see. The light is going to shine up through the specimen, so the slide would be sitting here, up through the specimen, and then up through one of these 3 things. And these are all called objective lenses. So they have a lens in them that will magnify the specimen first. So they magnify it to make it bigger, and then the image will be sent further on up through to where your eye is. Okay, so each of these is an objective lens. Okay, this one looks the longest, so it would be the high power. High power objective, and usually they would be 40x, and they would even say 40x on them. So they're going to magnify it 40 times. This one looks, these ones are harder to tell between, so I would make sure that you could tell. If I asked you on a test, I'd make sure it's easier for you to tell. So Let's say this one is the shorter one and this one is the longer of the two. So we'll call this one the medium power. Okay? And again, if you were asked on a test and you're not sure, you should be able to tell from the length of them, or you can ask and clarify. Okay, the shortest one is the low power objective. The medium power objective is usually 10x, so it magnifies it 10 times, and the low power is a 4x, so it magnifies it 4 times. This part here is it rotates, so you rotate it around using your hand, so it holds the objective lenses, the objectives, but it also allows you to rotate them and change which one you have in place. It's called the revolving nose piece. Okay, so revolving nose piece. Okay, so the light goes up through the specimen. The image is going to be magnified by the lens that's in the objective. Okay, so this objective lens goes up through the mirror in here, and it gets sent up through this part here. So this is called the body tube, and it carries the image from the objective lenses up through to the eyepiece. And of course, this one is the eyepiece, or the ocular, and it has a lens in it, so it allows us to view or look in and see the specimen, but it also has a lens in it, so it magnifies it. And it usually magnifies it 10 times. Okay, so if we had this high power one in place, then it magnifies it 40 times, and then it comes up through here and it gets magnified by another lens 10 more times. So the total magnification would be 40 times 10, 400x. Okay? That's how you figure out how much it's magnified in total. Now, this part here, okay, so this part here is called the arm. In some sites you might see it called the neck. The arm, or neck, is what holds, basically it connects the upper parts to the base of the microscope. It also allows us to carry it. So when we carry it, we hold one hand on the arm and one hand down here on the base. So this part here is the base. The base supports all the other parts of the microscope and allows us to carry it too. Now, these two knobs are for moving the stage and allowing us to focus on the specimen so that we can bring it into focus and see. So the bigger one is the coarse adjustment knob, coarse adjustment. Okay, it moves the stage really quickly, so it's only used on low power in order to bring it into focus roughly, okay, first, so that you can see it. The smaller one is the fine adjustment knob. Okay, so it's smaller. Now sometimes we have one knob that has a big part closer to the microscope and then a smaller part out here. Okay, so the big part is always going to be the coarse adjustment, and the smaller one, whether it's in a different spot or sticking out further, that will be your fine adjustment knob. So the coarse adjustment we use on low power first in order to basically find where the specimen is, move it quickly to find it. We use the fine adjustment knob in order to move the stage just a small amount at a time, and that allows us to kind of bring it into finer focus, see the finer detail. Okay, so we use it at the last when you're on low power, but it's the only one that you should be using when you get to the higher powers, so when you get to medium and high power. So that kind of goes through the parts and their functions of the compound microscope. In terms of caring for the microscope, there are certain things that you should be doing each time. Okay, and these are described in your book. On page 15, there's a little section here that talks about caring for your microscope, and you probably remember some of them from Miss Ramsey. I put some little graphics here just to remind you. So the first one talks about how you carry it. So carry it by putting one hand under the base and one hand on the arm. Second one talks about cleaning the lenses. So we don't use our fingers to clean the lenses because then we have fingerprints all over them and grease. So instead we use Kim wipes. Okay, guys. Shh. Sorry. Mac. Nay. Okay. Oh, one sec. Okay, so I think we did the first two. Sorry, I just had to talk to my kids for a minute. The third one says you shouldn't really adjust any of the focusing knobs until you're ready to use the microscope, but it's always quicker or more efficient too if you position it, you move the coarse adjustment so that you're either all the way to the top or all the way to the bottom, so that you kind of move one way or the other as you're trying to find the slide. Okay? Now, hopefully, whoever used the microscope last put it away properly. Okay, so when you start, because it should have been put away properly, it should always be on the low power objective. Okay, so you should always start on the low power objective, and you should always put it away on the low power objective. So you put it on low power objective, and you use the coarse focus knob, so the coarse adjustment, in order to move the stage fairly quickly and bring it into initial focus, to find it basically. Okay, so always focus first using low power and the coarse adjustment knob. Once you find it, you can use the fine adjustment to bring it into clearer focus, but you need to center it before you move. So just a little note here, center it before you move to the next objective. Otherwise, you're probably going to end up focusing on some random spot and not on what you want to see. So it needs to be in the center before you move to the next objective. Okay, so when you move to the next objectives, so the next one you'd move to is the medium power. Okay, then you use the fine focus, so the smaller knob. So on these pictures, it's showing them as one whole thing. So the big part closer to the microscope is the coarse adjustment. The smaller knob sticking out further is the fine adjustment. They're separate knobs on ours for most of them. Okay, so we only use the fine adjustment on the higher power objectives. Okay, so it says do not use the coarse adjustment knob when either the medium or high power lenses are in position. We only use the fine adjustment. Okay, the last one says cover the microscope when it's not in use. So when you're going to put it away, put it under low power and put the cover on it if it's available. A lot of ours are kind of no good anymore. So that's caring for the microscope. Alright, now using the microscope. This will help when you're working on your assignment, so it's more, there's one person who's going to be away, and so I wanted to kind of help her especially right now. The rest of you will be doing this when we're doing the lab. Okay, so the first thing that we're going to do when we look in the lab is kind of figure out orientation, what things will look like and how things move. So we look at the letter E. So you're going to put an E on your slide. You're going to make a wet mount of it. Okay, so on the slide, when you're looking at it and you put it under the microscope, this is how you're going to put it in. But when you actually look down through and you see that circle, okay, and you've got your E magnified, it is going to look like this instead. Okay, so if you happen to miss the lab, then hopefully this will help you. Alright? So, it is not only upside down, but it's also backwards. We call it inverted. Okay, so that is what happens. Then it asks you, okay, well, I want you to move, oops, what's happening there? What now? Okay, then I want you to move your E. What happened to my E? I don't need that anymore. Oh, I know something. I'm sorry, I need to go back to select. There. Alright. Oops. Good. Okay, so let's say I take the E and I move it on the side. I'm pushing it away from me. Okay, when I'm looking down, this is what's going to happen. Huh? So it moves opposite to what you physically move on the slide. If I move it up, then it's going to look like it's moving down. If I move it to the right, then yep, it's going to move to the left. So it has to go opposite. If you wanted to, let's say it's up here. Oh, let's say in the microscope it's up here, okay? And you want to move it down and right. So you would have to move it up and left to get it in the right position because it's the opposite. Okay, so it's tricky to get used to at first, but that's kind of what happens. Did you have your breakfast today? Okay, you could try that. Sorry. Okay, so that's kind of how things move. So there will be questions in the microscope, okay, or sorry, in the assignment, I think. There might have been one or two about moving things. How would you move it so that you can see, get it in the right spot? Opposite. The other thing that we'll be looking at in the first lab is we call estimating the size. But in order to estimate the size, we need to know how big the field of view is. Okay, so when we say field of view, we mean that circle space that we look at when you look down into the microscope. Okay, so if this is the microscope and I'm looking down into the microscope, it's always a circular thing that we see, and that is our field of view. Now, when we say field diameter, that's talking about the diameter. Diameter is the distance across the center of a circle from one side to the other. Okay, so the field diameter is basically describing the size of the field of view. The field of view itself, that circle, we always see a circle, like that circle is not going to change physically. But because we change the magnification, if we go to a different power objective lens, then it's going to change the field diameter for if we're estimating or figuring out the size of something. Okay? So because it's magnifying the image of what's in there, and their field diameter is what tells us, okay, how big something is in there. So if we had, let me see. Okay, so we're looking down into the microscope. I'm going to give you a clear ruler. And on low power, you can fit that clear ruler in here. Okay, so what you do is you set it so you can just barely see the edge of black. So I know that there's a line there. Okay, and then I'm going to measure. So if I take a pen, different color pen, let's see, blue. Okay, so I'd say 1, 2, 3, 4, 5, I'd say 5.5. Okay, so the closest we can really estimate is to the nearest half, halfway between two lines to be most accurate. Okay, so I would say that would be 5.5, and we're going to be measuring in millimeters. So don't use the inches side. We're going to use millimeters. So it'd be 5.5 millimeters. Okay, so if I said it's 5.5 millimeters, and that's not what you're going to see. It's going to be kind of close to that, but it's not that big. 5.5 millimeters, and it's going to say, oh, but we want to change that to more measurable units in the microscope, so we call them micrometers or micrometers. So to go from millimeters to micrometers, multiply, there's 1,000 micrometers in every millimeter. So we multiply. One moment, please. You are a great helper. Oh, you ask Nene if she'll get you some Oasis juice. Janae will. Okay, so 5.5 millimeters. So we multiply by 1,000 because there's 1,000. Oh, I can't do this very well with my notes. 1,000. It kind of looks like a written U for micrometers, in 1 millimeter. So if you think back to chemistry or math, when you're dealing with units, these units would cancel, okay? Because there's 1,000 micrometers in every 1 millimeter, and we have 5.5 millimeters. When we multiply, these units would cancel, and we'd have 5,500, 5,500 micrometers. Okay, so that's what we do to figure out the field diameter under both low power and medium power. It's a little trickier when we get to the high power because the ruler won't fit. Okay, so we can't directly figure out what the field diameter is. We have to use a calculation, and I'll help you with that in class. Okay? Now, the reason that we want to find out the field diameter is because if we know how big it is going across, I know the distance from one side of the circle to the other, then we can use that information to estimate the size of something. Okay, so the next part of your lab is going to be estimating the size. So we're going to take a little guy. This is a paramecium. So you guys are going to be looking at a paramecium under the slide, or under the microscope, sorry. And you're going to estimate its size. Now, it's pretty small, so you're going to focus on low power first, and then you're going to center him, and make sure he's finely focused on low power, center him, move to the medium power, focus again, center him, and then move to the high power, because he's pretty tiny. And if you left it on medium power, you're probably not going to have as good of an estimation of size. So to estimate the size, you want to try and get them as big as you can, so that you can get more accurate estimation. Alright, so if I wanted to estimate the size of this little guy, he has two dimensions we might talk about. So there's length. Length we usually tend to think of as the longer axis, or the longer side. So this would be his length. And then the width would be the smaller. So I would say the width goes this way. Okay, so if I know, let's say, 10, no, line. So if I know, I've already measured the field diameter, it's pretty big. Here's the field diameter. Make that a little thinner. There we go. Okay. So if I know the field diameter already, then I can say, oh, well, if this is, if we're on high power, you're actually going to see the field diameter will be probably, for most of your microscopes, will be about, sorry, the field diameter is going to be about 450 micrometers. Now, that should be a special U, but I don't know how to do the symbol at the moment in this, so we'll just keep going for now. Okay, so field diameter, so this distance across is 450 micrometers when I look under the high power. Okay, so all the way across is 450. So to estimate this little guy's size, I'm going to say, oh, well, if I could think of how many would fit lengthwise across here, so let's see, one, could fit another one here, another one here. Okay, so if I were to be super accurate, I would probably say, one, well, probably, to be most accurate, I'd probably say 2.5. I said 2.5 of them. Okay, guys. Thanks, Nay. Okay. Oops. I need the pen. Sorry, everybody's getting moving now this morning, so I'm down where they play games. Okay, so to estimate the size, I'm going to take this whole length, which I know is 450 micrometers, so the field diameter, I know it, and I'm going to divide it by however many I think would fit across. So it's an estimate because we aren't really positive, and I can't really take them and move them like I am right now on this slide, okay? But you kind of eyeball it, and you say, well, I think 2.5, would probably be okay if you maybe said 3, because it's a little more than 2.5, so I'd probably let that go. Okay, so if I said 450 is the length all the way across, and I'm going to divide it by however many fit all the way across. So if I said divided by, let's say 3, just to make it a little easier to calculate, then each one of these guys must be about 150 micrometers long. So that's lengthwise. That's in this direction. So this dimension. Okay. So good. Okay. So that is estimating the size of the length for the length. Now let's say instead I want to estimate the size of its width. So estimate its width. Okay, so that means usually when we say width, we mean the smaller dimension. So this way, we want to think how many can fit. All right, so again, the field diameter is still the same, 450 micrometers. Okay, I'm going to divide by however many we think would fit width-wise. So I'm going to take this again. I'm going to say, oh, well, I'm going to imagine. So you won't be able to actually do this when you're looking at a slide. But imagine, how many can I fit if they were to sit this way? And look at width-wise, how many of them would fit? Oops. Not doing a very good job. So, we'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, again, we're not being, it's not an exact science, it's an estimation. So if we said 10 all the way across is 450. So if I turn this, and I said all the way across. Ooh. All the way across is 450 micrometers. If I divide it by however many I can fit on there, so I divide by 10, and that should tell me how long each individual one is widthwise. Okay, so if I take 450 micrometers, micrometers, and I divide by 10, then each one should be about 45 micrometers wide. Okay, so if I were to look at this guy, then this way he's about 150 micrometers long, and this way is about 45 micrometers wide. Okay. That's it for giving you an idea what we'll be doing for when we do the first lab, but also for when you're doing your online assignment and it's asking you about estimating size. Probably a good time to stop because it sounds like they're starting to need some refereeing in here. If you have any questions, please don't be scared to ask. Okay, anytime. I'll try and reply as soon as I can.